Welcome to the chapter on Introduction to Python. Let's see what we'll be learning. We'll be seeing what programming is for the newbies. We will try to see how to install Anaconda and get familiar with using Jupyter Notebook. And we will have a rapid or a quick introduction to Python, which will cover mathematical operators, functions, control statements, conditional operators, data types, list, tuples, and dictionary, and how to slice the lists, tuples, and data from lists and tuples, and then we will also look at range. We will take just a few minutes to explain what a programming language is for the newbies. Assuming that you need to make a cup of coffee or say tea. First of all, you will look at the ingredients which are required for tea, for say tea leaf, milk, sugar, etc., etc. Then we will look at the steps which are involved in preparing the tea. First, we might be boiling the water, then we might be putting the tea leaves. So these are some series of instructions which we follow, or the series of steps which we follow to make a cup of tea. The same way, the computer needs to be programmed, or it needs to have a set of instructions in a particular sequence to do a particular task. But unfortunately, the computer understands instructions only in ones and zeros. So to communicate a real life problem to the computer, you need to create a specific type of text called a source code, or a human readable code that software can read and then process to the computer in ones and zeros. So let us look at these two terms. What is a program? A program is a sequence of instructions that designate how to execute a computation. Say I want to add 4 and 5. So we need to give 4 as a specific input type, an operator called plus, and then we also need to give an input of say 5, and we need to say add 4 and 5. And what is programming? Taking a task and writing it down in a programming language that the computer can understand and execute. So why only Python? Why not any other language like C, C++, Java? Let us look at the reasons why we would like to use Python for data science. Python is an open source, general purpose, high level programming language. Let us look at each of these keywords: open source, general purpose, and high level. When we say Python is open source, first, it is free. Secondly, it has a large and active scientific community with access to the software's code and contributes to its continuous development and upgrading depending on users' needs. So there is an active community which keeps on contributing to the Python software, and they have the access to the source code, and at the same time, because it is free, we can always have the flexibility of getting that upgraded code. When we say Python is general purpose, What we mean is there is a broad set of fields where Python could be applied. It could be applied in web programming, it could be applied for analysis of financial data, analysis of big data, etc. etc. And when we say high level languages employ syntax a lot closer to human logic, which makes the language easier to learn and implement. It is more closer to a 4GL language kind of a thing, wherein it is more English-like syntax rather than having a low-level syntax, just as we have in C or C++. So Python's popularity lies on two main pillars. One is that it is easy to learn programming language, designed to be highly readable with syntax quite clear and intuitive. Just as we discussed, it is more an English-like syntax. And the second reason is its user friendliness does not take away from its strength. Python can execute a variety of complex computations and is one of the most powerful programming languages preferred by specialists. In languages like C, if you want to just combine two strings, you might need to write, say, 50 lines of code. And that's the reason why it is more defined at a low level and also a low level language. So in Python, we already have those libraries wherein, within by using just a couple of lines of code, or maybe combining two keywords, we can say concatenate a string, because we have all those libraries available, which has been contributed by the community, Python community. And at the same time, it also gives an opportunity for everyone to be a part of that community, and they also can contribute to the Python code because the source code is accessible. What softwares do we need to pursue this course of data science? At this point of time, we will look at the two important softwares. What we need is, one is the programming language Python itself, and the other one is called a Jupyter Notebook app. Can't we do everything in the Python programming language itself? The answer is no. Python programming language allows us to communicate with the computer. We would need a software named Jupyter Notebook app, which is a server client application that allows us to edit our Python code through a web browser. Let's look at the following graph. On the left side, we have several language kernels. For example, Python, R, Julia. Now, these are softwares which are supposed to read and execute code in a particular programming language. So these are basically called language kernels. The Jupyter installation always comes with an installed Python kernel, and the other kernels can be installed additionally. On the other side, we have various interfaces where the code is written. They represent the clients, for example, web browser, and there are other interfaces also. The Jupyter server provides an environment where a client is matched with a particular language kernel. For example, If you write code in Python, it is going to match to a Python kernel for reading and executing your code. In our case, we will focus on the web browser as a client and the Python kernel in this course. So our work is stored in a notebook document called an IPython notebook document, also with an extension of IPYB file. Something like this, a notebook file name with an extension of IPYNB file. So here, instead of installing a separate front end for each type of kernel, there is only one Jupyter Notebook which we can use to connect to different language kernels. For example, if you have a PHP file or a Julia file, all of them are stored in a notebook file, maybe with a separate extension, but all of them work under the same Jupyter software. So here is what it is. The Jupyter Notebook app is a server client application that allows you to edit your code through a web browser. So as we said, this are the language kernels and a front-end interface where you write the code. So that becomes the client and the language kernels become the server. So the language kernels are programs designed to read and execute code in a specific programming language, like we saw in the previous graph, like Python, R, Julia. Jupyter installation always comes with an installed Python kernel, and the other kernels can be installed as and when you want. The interfaces where you write code represent the clients. An example of such a client is the web browser. And the Jupyter server provides the environment where a client is matched with corresponding language kernel. So if you're writing a code in Python, it will match with the Python kernel. If you are writing a code in R, and if you have installed the R kernel, it is going to match your code with the R kernel. So in this course, we will be discussing more about Python and web browser as a client. So if you are a new user of Python, it is highly recommended that you install Anaconda. Anaconda comes with Python, Jupyter, as well as a lot of additional packages and libraries which are used in data science. Click on www.anaconda.com, and once the site is opened, click on the download button on the right side of the page. You must pick one of the three operating systems listed here: Windows, Mac, or Linux. In this lecture, we will show how to install Anaconda on Windows. So the procedure for installing in Mac or Linux is the same. Remember that all these are open source and the community keeps on updating the versions very frequently. So most of the functionalities will remain the same. There could be slight changes of the interfaces here and there, which you need to keep on checking time to time. For the Python versions, it is always advisable to update the latest version. But before choosing a Python version, just make sure that your operating system is a 64-bit OS. If it's a 32-bit, you need to install a 32-bit Python version. So ideally, we will choose Python 3.7 with a 64-bit installer. Also, Some packages like TensorFlow is compatible only with Python 3. So we should go ahead with installing Python 3.x version. So now click on the download button and you'll be presented to where to save the installation file. So once you choose a particular directory or a folder of your choice, click on save. Now go to the folder where you copied or downloaded your installation file and run it. And what happens next is a series of windows uh, showing some information of the installation. Just click on next, I agree, and all this until you reach a particular window where it asks to choose a destination folder. So once you choose your destination folder and have finalized it, click on next and you will be prompted with this kind of a window. I would suggest that you choose the default selected options, which is the second one, which is register Anaconda as my default Python, and click install. So you will be taken to a window wherein the Anaconda will be installing, and finally it will present you with an information that Anaconda has been installed successfully. So further windows, if they ask any information, for now just press skip and proceed. And finally click on finish. So what you would have finally installed is a whole Anaconda distribution, which includes Python language, a lot of packages, uh, Jupyter Notebook, and other text editors, and etc. etc. So once the installation is complete, you go to Program Files, search for the Anaconda distribution we just installed, and click on Jupyter Notebook. It will take some time and it will open the Jupyter Notebook for you, just like this. So we will try to get familiar with Jupyter Notebook's interface. So as soon as you load the notebook, the Jupyter Dashboard opens. Each file and directory has a checkbox associated to it. By ticking and unticking an item, you could manipulate the respective object. That means you can duplicate or shut down a running file. We'll just try to see with some example. If you see here, when we open this Jupyter Notebook, we have the listing of the current directory. Normally, we are pointed to the users directory on your C drive or the system directory. So we have these checkboxes associated to each item. We can also have files, and based on what we select, the menu here changes. See, duplicate, move, view, running clusters. These menu items change based on what we select. If I select a folder, the menu item changes to rename, move, edit. So let us try to play around with the UI. Let us start with this drop down menu. You have the option of selecting, say, all the files. If you click this files, see all the files in the current directory are selected. So if you again click this number, they're all unselected. The same way, if you want to select all the folders, it selects all the folders. And then if you want to unselect, just unselect them. You can select a folder and say rename to rename the folder name. You can also select a file. For example, let us select untitled1 Python file, and when it opens, if you look at the state of the file, it is changed to running. So in this case, this Python assumes that the file is loaded. So if you want to unload the file, you need to specifically select that file and say shutdown. From the upload button in the top right corner, you can upload a notebook into the directory you are in. So normally you will be working in the users directory or the system directory in your C drive. So you can actually upload a file from some other directory to the current directory, the current working directory, using this upload button. You can expand the new button. From the list that falls, you will most likely need to create a new text file, a new folder, or a new notebook file. So here is where we select the upload button. It opens the file selection, and you can browse to a particular directory and a folder, and you can select a particular file to load on. The new drop down contains a lot of other options like Python 3, text file, folder, terminal. When you select Python 3, it is going to open a new Python file for you. So if you look at this menu, you have Python 3 listed under the notebook section. So if you have installed any other kernel language, kernel as we discussed earlier, it would have got listed here, and you could have opened a notebook file for that particular language. So when we create a new Python file, it creates a file with an extension of IPYNB, which is IPython notebook file. Once you create a new Python notebook file, you will be presented with something like this interface. Now, this particular area is called the cell, where you start typing your code. So you can access the cell by pressing enter. Once you have done that, you will be able to see the cursor. You can start typing the code now. This area marked in green, this particular cell, is called an input field. When you execute a code in input field, there may be another line saying out this marked area down, which is called an output field. So you can execute a command in two ways. First, look at this top area wherein we have a command entered in the input field, and then we press Control plus enter. So the machine executes what is there in the input field, and you will still stay there, meaning I will not have created or selected another cell. Now let us compare that with the image the down, wherein we input a command, say x is equal to 1 2 3 4, and then we say x, and then we press shift plus enter. In this case, after displaying the output, there is a new cell which is created, and your cursor points to the new cell. So let us try this live. On our Jupyter Notebook, we say x is equal to 1, 2, 3, 4. We're creating a list, and say x, and I say control and enter. So here if you see, it has created a new cell, out, but it has not created a new input field. Now with this same example, now I say shift enter. If you see, now it has given an output of 1, 2, 3, 4. It has also created a new input field which is marked in green, and the cursor is pointing in the new input field. There is something called a markdown cell which we can create. A markdown cell is a cell that contains strictly documentation, text not executed as a code. The parser will skip executing if the cell is a type of markdown. So it will contain some message you would like to leave to the reader of the file. So how do we create a markdown file? You can select a particular cell and then select this drop down and change the type of this cell to markdown. If you say hash XYZ, this is a markdown cell. So this code becomes a comment. So we will be dealing more often than not with something called variables. Variables you can imagine as a temporary storage. We store information in variables so that we can manipulate them to arrive at a decision. So one of the main concepts which most of the languages use is variables. Let's say you want to have a variable x that is equal to the value of 5. So we store a value of 5 into x and then ask the computer to tell you the value of that variable. Type x equals 5, then write x and then execute. As we discussed, we can execute with a control enter or a shift enter, and the result is a 5, which is shown in this output field. So we assign a variable, declare a variable, and then assign a value of x is equal to 5 and say shift enter. Now when we say show me the value of x, I can say x and shift enter. The output field shows a 5. Another way to execute the instruction that will provide the value we assign to x or y in this example is using the print command. So instead of just saying x and there is an output field which shows 5, we can also say print x. Just like this, you can say x is equal to 6, print x. So we are presented with an error saying that missing parenthesis in call to print. Now probably we missed this. When we execute again, we get the value of x as 6. The syntax could change from version to version, so we need to sometimes keep ourselves updated. In a programming language, not only in Python, if you say that a variable has a numeric value, you are being ambiguous. The reason is a numeric value could be a whole number, a decimal. So each of these types of variables have a way of representation or declaration in every programming language. So what is an integer? A positive or negative whole numbers without a decimal point is an integer. So when we say x is equal to 5, X contains an integer type. Floating point, also denoted as float, they're real numbers, hence they have a decimal point, say 4.75. If we say y is equal to 4.75, we are assigning it is y is of type float because we are assigning a decimal value to y. A Boolean value, a true or false value corresponding to the machine's logic of understanding ones and zeros, on or off, right or wrong, true or false. So a Boolean value in some languages are also expressed in zeros and ones. A variable can also have strings. Strings are text values composed of a sequence of characters. You can enclose a string with a single quote or a double quote. So in this case, if you see the example here, George is in single quotes, and when you say shift enter, it displays George in a single quote. At the same time, you can use a print command to display George, and in this case it will give an output without the single quotes. You can also declare a string in double quotes. The behavior is the same. So here we are not storing the value of George in a variable. We are just trying to display a particular string in the Jupyter Notebook. So GEOR. When we say George, it displays George. You can also display something like this. The value is going to be the same. Say print G. Now it displays without a single quote and without that output field. The strings are text values composed of a sequence of characters. So let us look at this example where it displays I am fine, and you need to display the single quote between I and M also in a string. So in such cases, put the text within the double quotes and leave the apostrophe as it is. So we enclose the whole string within double quotes. Another way of doing the same thing is by using escape characters. This backslash between I and M here ensures that this particular escape character of a single quote is treated as it is, and it distinguishes between the outer single quote layer and the inner single quote layer. So here in this example, suppose we wish to print this red space car. So we add two strings with red and car, and if you see here, after this red there is a space, and when we say use this plus sign, it concatenates red and car. Same way, in the second example, we have a print statement with red comma car. Both these can also be stored in a variable and then concatenated and printed. For example, I say A is equal to red space, B is equal to car. I want A plus B. Let's say shift enter. It displays red car. So here what I have done is I have stored the value of red, the string red, In a variable called A, I have stored the value of car in a variable called B, and I am concatenating the two strings by using this plus symbol with A plus B, which displays me the final concatenated string as red car. We'll look at what an arithmetic operator is. So given this example here, 1 plus 2, this equation, 1 and 2 are called operands. The plus and minus are called operators, and given they also represent arithmetic operations. It represents an addition operation. So they are called arithmetic operators. So let us look at these operators. Plus operator is used for addition. Now, if the operands are number values, the plus operator displays an added value. If the two operands are strings, as we saw in the previous example, it would have concatenated the two strings. Minus operator is used for subtraction. Slash operator is used for division. This percentage, also called the modulus operator, is for remainder. So if we divide 5 by 2, we would get a remainder of 1, and the modulus operator gives us that 1. The star operator is used for multiplication, and double stars are used for power calculation. Say 2 to the power of 3. So we can say 2 star star 3. We will look at an equality operator and a double equality operator. Equality operator is normally used to assign values. For example, in this, we have y is equal to 5 star star 3. Remember, star star is used for power calculation. So we are assigning the value of 5 star star 3 to y. So 5 star star 3 will evaluate to 125, and that 125 will be assigned to a variable called y. While we use double equality, it is used to evaluate a true or false statement. Normally, it is used with if and while and the control statements, which we will be discussing later. So when we say y is equal to 125, what it means is y is equal to 125 is what it evaluates, and it is going to come back with an answer, say true. Is y is equal to 126? No, so it is going to return a false. We say y is equal to 5 star star 3, and now we say print the value of y. It says 125. Now we ask a question saying y is equal to 125. It says true. Again we ask a question, is y equal to 126? It comes back with an answer saying it's false. How do we assign and reassign values? Suppose we have a variable called z, and we have assigned a value of 1 to z, and then we print z. The value displayed is 1. Now we again say z is equal to 3, and when we try to print z here, it prints 3. So the value of 1 is lost. So here Z is overwritten with the latest value. So the next statement, when we say Z plus 5, in its memory it has the value of 3 and it evaluates 3 plus 5, which is 8. And in this last input, fourth input, when we reassign Z is equal to 7, Z is assigned the value of 7 and it prints the value. What are comments? Comments are sentences that are not executed by the computer. It doesn't read them as instructions. So how do we put a comment? We just put a hash symbol in front of a statement which we don't want to execute. And the Python interpreter reads that as a comment and it does not execute. So if you want to add multiple lines of comments, you need to start every line with a hash symbol. So in this example, in first input, we have said this is just a comment and not code. And we have started this particular line with a hash symbol. And then we have said print 7, 2. So when we execute this particular line, the first line is ignored by the Python interpreter and it executes the print statement and it prints 7 and 2. Sometimes we would have a line spanning multiple rows, or we would like to span our command span multiple rows so that it can be readable. So in that case, suppose we want to execute say 2.0 star 1.5 plus 5, instead of putting in the same line, if we want to extend that 5 to the next line, but we still want to execute it as a single command, at the end of each line, we can place a backslash. So when the Python interpreter executes this backslash, it knows that the next line is a continuation of the current line and it executes it as a single command. Assuming that we have a string named Friday, this is in the form of an array wherein we have the square brackets. If we want to extract the letter D, how do we do it? We need to know the position of D in the string Friday. So if we want the letter D, we need to specify Friday square brackets a value of 3 inside. Why do we put a value of 3? So in Python, in a string, the first letter will have the position of 0. The second letter will have a position of 1. So in this case, if you see, F has a position of 0, R has a position of 1, I has a position of 2, and D has a position of 3. So if you want to extract D, we need to specify the string with the position ID as 3 inside a square bracket. In Python, indentation is very important because that is the only way to communicate your ideas to the machine. Unlike other languages where you have brackets or end, etc., to specify the end of a block of a code or a function. In Python, we have only the indentation practice which defines that the block of code is ended here or starting here. Looking at this example here, we say def to define a function, say 5x. Now there is an indentation here, and then after that we say x is equal to 5. Then again there is an indentation here, and we say return x. Now if you see, x is equal to 5 and return x are exactly placed at the same indentation level. Now if you want another statement which is not a part of this function, you need to start it with a fresh or the first indentation at the first indentation level. Say print 5 in the brackets 3, which means that this print statement is not a part of the def function block. So here you need not, or Python doesn't have the practice of specifying an end value or an end statement for a function or a block of code. It is only the indentation which decides, and that is the only indicator to the Python parser that the print statement, for example, here is not a part of the def block and it is a fresh block. Let us look at some more operators called comparison operators. A comparison operator equal to, which we saw earlier for evaluating a Boolean value, verifies the left and right side of an equality. So if we want to say 2 is equal to 3, it will evaluate to false. Whether 0 is equal to 0, 1 equal to 1, it will evaluate it true. So whenever we want to compare two values, one on the left and the one on the right side, we use an equal to operator. The next one is not equal to. Verifies the left and right side of an equality are not equal. So if 2 is not equal to 3, will be denoted with this kind of symbol. Then there is a greater than operator, less than operator, greater than or equal to, and less than or equal to. Logical operators. The logical operators in Python are the words not, and or. They compare a certain amount of statements and return Boolean values, true or false. So to test a logical operator, we need at least two expressions, one on the left side and one on the right side. Let us look at this from an example. We have declared two variables x and y. X has a value of 2 and y has a value of 5. Now we first check the AND operator, wherein we are checking whether if x is equal to 3 and y is equal to 5. We have declared x as 2, but we are checking whether x is equal to 3 and y is equal to 5. Now this expression evaluates to false because we have one of the expressions on the left hand side as false. X is not equal to 3, you see, it is equal to 2. Now if we change this to 2, because both these expressions now evaluates to true, the AND operator will evaluate to true. So for the AND operator, all the expressions involved needs to evaluate as true. Let us check the next example wherein we use the OR operator. Here we are again checking whether x is equal to 3 or y is equal to 5. Now here x is equal to 3 evaluates to false because x is equal to 2 and y is equal to 5 evaluates to true. Now either one of them evaluates to true, so the OR operator is going to return a true. The third example, we are checking the NOT operator. We are checking whether NOT of x is equal to 2, which means x is not equal to 2. Now, this returns false because x is 2. Now, if we change this to 3, the NOT operator is going to return a true. There is also the order of importance or priority which needs to be followed. So the NOT comes first, then we have an and finally OR. So if we have an expression wherein we have all the three operators or more than one of these operators are used, so if there is a NOT, it will be evaluated first, then the and finally the OR. There are also something called identity operators. The words are is and is not. So they function similar to the double equality sign and the exclamation mark and equality sign which we saw earlier. For example, let us look at this first input field. 5 is 6. No, 5 is not 6. It evaluates to false. So is 5 equal to 6? It evaluates to false. So these two statements are similar, except that this is using an is identity operator. This is using the double equality sign. Next is 5 is not 6, which is true. So we can also use not equal to 6. 5 is not equal to 6, which also evaluates to true. So let us look at some of the conditional statements now. A prominent example of conditional statement is the if statement. So if a condition is true, then execute a piece of code. So the syntax for this is here, if 5 is equal to 15 divided by 3, print hooray. Yes, 5 is equal to 15 divided by 3, so it is going to print hooray. Note that the block of if statement ends here and the next statement is indented after the if statement in the first line. So as we discussed earlier, this print statement will be a part of this if block. There is also an else statement complementary to the if statement. Else statement will tell the computer to execute the successive command in all other cases. For example, here we declare x to have the value of 1. We check if x is greater than 3. Then print case 1. Else print case 2. Now x is greater than 3? No, it is not. So it is not going to execute this print statement. It is going to come to the else part and it is going to print case 2. We also have another statement called elif, ELIF, wherein we can have multiple if statements. For example, here we declare a function where it has an argument, a parameter of y, and this y could contain any number. So the function checks if y is greater than 5, then it returns a string greater. Elif y is less than 5, it is going to return a string less. Else, if none of the if and elif match, then the control is going to come to this else and it is going to say they're equal. We could have multiple elif statements, and we can also have multiple expressions within each if and elif. We can also check elif y is less than 5 and y is greater than 2, return something. What is a function? Why do we need a function? A function in any language is a block of code which can be used to evaluate again and again. And the biggest advantage of a function is that it can be reused at any point of time. So how do we define that block of code called function in Python? We use a keyword called def with a name of a function and then a colon to end the declaration of the function, and then we write the function body as series of instructions which we want the function to execute. So here we have declared a function named simple. Once you name the function, you need to have this brackets and then a colon. So there is a keyword specified as def before the name of the function, and then in the next line we have said print my first function. Again, notice that there is an indentation after the first line. In the second line, if you notice, there is the print is indented, and this is how the Python recognizes that it needs to execute a function block now, because there is a new block. It encounters a new block with a keyword called def. So let us look at how to define a function and how to call that function. Suppose we want to have a value of plus 10 to any value what we decide on. Suppose we want to add a value of 10 to say 2. So now we define a function block with a name plus underscore 10 with a parameter called a, and the function returns a value a plus 10. So whatever the value of a, it is going to return, add 10 to it and return the value. And how do we call this function? We just say plus 10 plus underscore 10, and we pass the value for which we need to have plus 10 value. So here we have passed 2, so the function returns 12 to us. Tomorrow we might pass 4 and we might get a value of 14. So this function can be reused at any point of time for any other number also. So if you want to create a function with multiple parameters, you can always have them separated with a comma value. So here we have subtract underscore bc with 3 parameters a, b and c, and each of them is separated by a comma. We declare a variable called result, which is equal to a minus b into c. So the a will contain some value, b will contain some value, c will contain some value, then we call it, and the function then returns the variable value of result. So here we have declared a function plus 10 then with a parameter x, and whatever the value of x, it is going to return, add 10 to it and return the value. And then I call this function with a value of 4. So this 4 goes as an input to this function. This function is called, and 4 becomes the value of x, and then it returns the value x plus 4, 10, which is 14. Now I declare another function called plus underscore where with two parameters x and y, and I return the added value of x and y. And then I call a function, the same function plus where, with the value of 4 and the value of 5. Now the 4 goes into x, 5 goes into y, and this calls this function plus where with 4 and 5 as parameters and returns me the value of 9. Now let's look at some of the built-in functions in Python. So when you install Python on your computer, you are also installing some of its built-in functions. These built-in functions will actually come as part of some of the packages of Python which are pre-installed. So what this means is you won't need to type their code every time you use them. These are always available for you. So let us look at some of these built-in functions. First one is type. This obtains the type of variable you use as an argument. Then there is an int. This transforms its argument in an integer data type. Suppose if you say int of 5, so it will make sure that this 5 becomes an integer type. Float transforms its argument in a float data type. So if you say float of 5, it might transform it to 5.0 or 5.00. Then string str transforms its argument in a string data type. Max returns the highest value from a sequence of numbers. Min returns the lowest value from a sequence of numbers. ABS allows you to obtain the absolute value of its argument. The sum function calculates the sum of all the elements in a list designated as an argument. Round x comma y returns the float of its arguments x rounded to a specified number of digits y after the decimal point. So if you say round of say 5.1234 comma 2, so it will round it to 5.12. Power of x comma y returns x to the power of y. Len function returns the number of elements in an object. So here is what it is. I'm saying float, I'm passing an integer 5. So it converts this 5 into a float and it returns me 5.0. This is a built-in function which we are trying to use. So here in another example, I'm saying round of 3.4567, round to the 2 digits after the decimal point. So it has rounded it to 2 decimals. It says 3.46. I'm using the built-in function power here. Power of 3 comma 4, which is 3 into 3 into 3 into 3, or 3 raised to the power 4, which returns me 81. What is a list? A list is a type of sequence of data points such as floats, integers, or strings. How do we define a list? We define a list like this. A list participants is equal to square brackets John, Leela, Gregory, and Kate. Now, this is a list named participants which has a string John in as its first element, Leela as its second element, Gregory as a third element, and Kate as a fourth element. Now, the indexing of this list always starts from 0. So suppose if we want to extract Gregory, now Gregory will be in the second index, that is 0, 1, 2, which is the third item from the beginning. So we can say participants square brackets 2 will give us Gregory. We can also extract the value of a list from the last. Now, the last element has an index of -1. So when we say participants of -1, we are going to extract Kate. So here I have declared a list named L1, which is equal to 1, 3, 5, and 7. It contains 1 as its first element, 3 as its second element, 5 as its third element, and 7 as fourth element. Then I have said L1 of 2, which is the indexing starts from 0, 0, 1, 2, which returns a value of 5. So how do we call methods? The methods are always called with the syntax of object.method. Now in our previous example, the list was an object. So the participants was a list object which contains a method called append. So in order to invoke the method of an object, we use the dot operator. So we said participants dot. So the list object contains a method called append, which is used to append an item to the end of the list. So if we want to add Dwayne to the end of the list, which already exists, named participants, we need to say participants dot append Dwayne. So here I am trying to append a value, a new value, say 9, to our list L1. So I say L1 dot, and if you press tab, it will list me all the methods which are available for my list object L1. So I have done an append to L1. I've added a value of 9, and then I'm seeing what the listing the values for L1. Now it shows me 1, 3, 5, 7, and 9. 9 has been appended to the end of the list. Now if I want to add a complete list to an existing list, I need to use a method called extend. So what I have done is I have added 11 and 14, a new list, to an already existing list named L1 by saying L1.extend a new list 11 and 14, and then I have listed the values for L1, shows me 11 and 14. Slicing is referred to extracting a portion of data from a larger set of data. So how do we do slicing in a list? We have a list assigned with a few values: John, Leela, Maria, Dwayne, George, Catherine. Assuming that we are interested only in Leela and Maria. Now, we discussed earlier that in Python, the indexing starts from 0. So the index of Leela is 1 and the index of Maria is 2. 0, 1, 2. So how do we do slicing in Python? We use this colon operator. Now, when we want to extract Leela and Maria, the first element will always correspond to the first position, and the last element which we want to extract will be the actual position plus 1. So if Leela is 1, 0 and 1, Maria is 2, we would say extract from 1 to 3. So in our example here, we're extracting 5 and 7 using extract from the second position till the end should be 4. This position is 0, 1, 2, 0, 1, 2, 3 plus 1, 4. So which is going to give me 5, 7. What are tuples? Tuples are another type of data sequences, just like lists, but they are immutable. Tuples cannot be changed or modified, which means that you cannot append or delete elements. So for a list where we used square brackets, here we use rounded brackets. We declare a tuple with say x is equal to 40, 41, 42. So tuple is the default sequence type in Python. So if you list 3 values here, the computer will perceive the new variable as a tuple. We could also say that 3 values will be packed into a tuple. Dictionaries represent another way of storing data. Here we have something called a key value pair. Let us look at this with an example. We declare a dictionary dict, which is equal to, we start with a curly braces here. The first value is the key and the second value is the value. So we say K1 has a value of cat as the first element of dictionary. Then we say K2 has a value of dog as the second element of dictionary. K3 has a value of mouse, third value of dictionary, and K4 has a value of fish, the fourth value. Now if we want to extract the value for the key K1, we need to give the syntax something like this. Dictionary dict of K1 within a square brackets. When we provide a key value, it is going to it is going to give us a value for that key which was stored in the dictionary. We can also add a new value to the dictionary as we added in the list with saying that dict K5, a new key, is equal to its value, say parrot. So this will append a new key called K5 to the existing dictionary, which means that it will append it to the end. We will now move to some iterative mechanisms. So let us look at the for loop first. An iteration is a fundamental building block of all the programs. It is the ability to execute a certain code repeatedly. So first comes the for loop. In this example, the list even contains all the even numbers from 0 to 20. For n in even colon, which would mean that for every element n in the list even, do the following. Let us look at this with an example. We already have a list named L1 which contains 1, 3, 5, 7, 9, 4, 11 and 14, which we declared earlier. We declare a for loop and say for n in L1, which means that for each element in L1, now that each element with every iteration will get into or will be assigned to n, and then we print n. So for the first iteration, n will have the value of the first element of this list, which is 1. It prints 1. The second iteration, it will have the value of 3, which it will print 3. For the third iteration, it will have the value of 5, and it will print 5, and so on. So it keeps on printing until it prints the last element, which is 14. Now let us look at another variation of iterations called while loops. So in while loops, we iterate the loop until a particular condition is reached. So we specify the condition in the while statement. In the example here, we are trying to print all the even numbers between 0 and 20. So we initially set a variable x with a value of 0, and then we specify the condition wherein x is less than or equal to 20, which means that it is also going to include 0 and 20. And within the while loop, we are saying print the value of x, and we also need to increment x with a value of 2. As against for loop, where there was an auto increment or increment was taken care by the for loop itself, here we need to specifically provide an incremental statement saying x is equal to x plus 2. So let us look at this from the example. Here I have set a value of 0 to z, and we are then iterating z until it reaches 20. So from 0 to 20 it is going to iterate. Initially it is going to print the value of 0 as a first statement, then it's going to increment z to 0 plus 2, and z will be assigned the value of 2. Then again, when this comes back to the while loop, it checks whether z is less than or equal to 20. Yes, at the moment z is only equal to 2, it is going to print 2. Then it is going to increment z again. So initial value was 2, now it is going to become 4. Now again the while loop will iterate. Now it will check z, 4 is less than or equal to 20. Yes, it is going to print 6. So again, the same way, this keeps on going and iterating. The while loop keeps on checking the condition, whether the condition is reached. As soon as z becomes 20 plus 2, 22, this while loop, 22 is less than or equal to 20? No. So it is going to terminate and it is going to come out. So another common way of representing the statement x is equal to x plus 2, you can also specify x plus is equal to 2, which would evaluate to x is equal to x plus 2. We can also create a list with an inbuilt range function. So when you need to randomize data points and lists with data points, you can use Python's built-in range function. The syntax for range function is range, the start point and the stop point, and an optional step point. So the start point is the first number in the list, stop point is the last value plus 1 in the list, and the step is the distance between each two consecutive values. The stop value is a required input, while the start and step values are optional. So if not provided, the start value will be automatically replaced with a 0, and the step value would be assumed to be equal to 1. So in the first example here, we say range of 10. Because the start value is optional and we did not provide, it took it as 0, and it has given values from 0 to 9, which there are 10 elements. The second example says range 3, 7, which means the start value is 3, the end value is 7 minus 1, 6, 3, 4, 5, and 6. The third example says range 1, 20, 2, which means the start value, the end value, and it says step count should be 2. So when it says step count is equal to 2, the distance between every element will be having a space of 2. So from 1, there's a space of 2, 3, then 3 to space of 2, 5, 5, 7, 9, 11, and so on till 19. So in this example, we try to use the conditional statements and loops together. So we have used a for loop where we say for x in range 20. So it declares values from 0 to 20 and then it iterates. For each value of x, it assigns, the first iteration it will assign 1. If it checks whether x modulus of 2 equal to 0, then it will print x, else it will print odd. Okay, so it is actually checking the modulus of 2, which means that if it is an even number, it is going to print the value of the even number. Otherwise, it is going to print the statement odd. So in this example, we are using both the for loop and the if statements together. So let us get some hands-on on Python. You can open a Jupyter Notebook also by opening a command prompt and typing Jupyter Notebook. For this, you should have set the environment's variables path to the Jupyter executable in your operating system. So once you give this command, it is going to take some time and open the Jupyter Notebook interface for you. So when you open the Jupyter Notebook, it is always going to point to the users directory. So by default, when you create new files, it will be stored in your users directory in your C. I can say new notebook of type Python 3 and it opens up a new file for me, which will be named as IPython notebook file, IPYNB file. So untitled 14 is the new file which has been created for me, where I can write my Python commands. Here you see untitled 14 IPYNB under my users directory. I can do a save as of this file and give this path or any path wherever I want to store, and I can save the file as, say, exercise. If you see here, a file with exercise IPYNB has been created in my users directory because I saved the same untitled 14 file as exercise file. Now I can start typing my commands in this input window. Then to execute, I can either say Control Enter or Shift Enter as we discussed earlier, or I can also use this menu, run, pause, and all these toolbar buttons. So let us do some exercise on this Python. So basic command which I am going to use as my first exercise is print 1 to high 4. So if you see, I have listed the first line as a comment using this. I could have also added a new comment line by changing this to Markdown and entering the command in another input field. Still, we can do the same way, which is much more easier. So I say Shift Enter here. It has printed 1, 2, high and 4, and it has also created a new input field. And the cursor is pointing to the new input field. So we'll continue doing some exercise. This next command I am trying to print 2.45, and I'm also typecasting 2.45 to an integer value and then trying to print it. See what's the answer. So because I'm typecasting a float value of 2.45 to an integer, it has considered only the whole number part of the decimal number. So the 0.45 is truncated because we are specifically typecasting it to an integer type. In this example, we are trying to print 1, 2, 3, 4, 5 as a string. So now the string is enclosed in a double semicolon, double apostrophes. So to print a string, we have to provide this double quotes and then press enter. So 1, 2, 3, 4, 5 is printed as a string. Here, in another example, we are trying to print the string print today is 4 July. So we declare a variable called x, assign it a value of 4, declare another variable y, assign it a value of July, and there is also a space. So y is a string and x is an integer, and then we say print with double quotes. We say today is space, and then we say x comma y. Now this print command is going to typecast internally everything to a string, and then it is going to print the string today is 4 July. So let us look at another example where we are taking an input and putting that value of the input into a variable called name and then trying to print the name. So here we say name is equal to input. What is your name? Here the system waits for our input. Suppose we say x, y, z. Then it says hi x, y, z. It's going to execute this statement. Hi, whatever you have input as your name, it is going to say hi x, y, z. Hi with that name. Now here the cursor waits for the user to provide an input. In this example, we try to calculate the area of a rectangle using input statement. Remember, the input statement is going to wait for the user to input something. So in the first statement, we are assigning a variable length and we are saying input enter the length of the rectangle, wherein the system is going to wait for the user to input the length, and once the user gives the length, it is going to assign it to the variable length, and then the next statement it is going to typecast the length into an integer because the user input will be always a string, and then it is going to assign it to another variable called L. Same way, it is also going to ask for the breadth from the user, then typecast the user input of the breadth to an integer and assign it to another variable called b, and then print the area of the rectangle as the typecasted value of length, which is in L, and the typecasted value of the breadth, which is in B. So remember that any user input is always a type of string, and you need to typecast it to an integer if you want to perform integer operations like multiplication. So let us see how we do it here. We say length of the rectangle. So I say 12, enter, and enter the breadth of the rectangle. I say 12, and it should give the area of the rectangle as 144. In this example, we are going to use a float value, a decimal value, to calculate the area of a rectangle. The same way, it is going to take length as an input, and it is going to typecast this time to a float value, to a decimal value. So if you say 12, it might be 12.0 internally, which will be stored in L. Same way, depth will be stored as a decimal value. So let us try to execute this. I say 12, depth of the is again I say 12, and here the answer is 144.0, which is a decimal value, a float value, as against what we had earlier as an integer value of 144. That is because we have typecasted the input to a decimal value using this float keyword. You can always go ahead and save your work at any point of time using this save button, and this exercise will be always stored in your IPYNB file. So let us move to some advanced topics. We discuss something called a tuple, which is a list of items, but we cannot modify a tuple. So we'll declare a tuple called first tuple with items 12, jack, 45.6, new, and also another tuple inside, and another string test. If you see, there are different types of items. One is an integer, one is a string, one is a float, one is another tuple. So this first tuple has a variety of different items inside it. So we say first tuple, and it gives me the output of what and all is there in the first tuple. Say first tuple 1, it gives me the value jack. Remember, we discussed that in Python, a list, a tuple, and a dictionary will always start with an index of 0. So when I pass an index of 1, it gives me the value in the index 1, which is jack. Now I say first tuple 1 mark. Now, so here it says, see, you are trying to assign a value to the first index mark. You're trying to change the value of the first index. Instead of jack, you want to replace it mark. So as a tuple cannot be modified, it throws an error saying tuple object does not support item assignment. You say first tuple of -3. So it prints new. -1, -2, -3. The last position is -1, as we discussed earlier. Now we try to do a slicing from position 1 to position 4 of the tuple. What we get is position 1, that is 0, 1, jack, 45.6, 2, and new 3. Position 1 to position 4, 1, 2, 3, fourth position is the new one. In this example, we are trying to slice from the first position to the last position, which is again the position -1. So we get from the first position before the last position. Here we are declaring a list called first list with items as mark, 101, 23.6, test, none, and 11. Now we say first list, and it gives us the list of items which are there in the variable of type list, first list. Here, the next example, we are trying to append an item jack to the list named first list. So when we say append jack, and again when we say first list, you can see the jack is now appended to the first list. In this example, we are removing an item called mark from the first list. Now again we say first list, and see mark is now removed. In this example, we use a method called pop, which is a method of the list. So since first list is a type of list, we can use the method with a dot operator, as we discussed earlier, object dot method. So what it has done is test has been popped out of the list. 0, 1, 2, 0, 1 and 2. This is our latest first list. The test is at the second position, so it has popped test out of the list, has removed it. If I list first list, you can see that test has been removed. Now here, say first list dot insert, the first position I am inserting Smith. Now again, if I try to list, see what is there in the first list, it has inserted Smith to the first position after 101, which was position 0. It has inserted Smith position 1. Here we are trying to list the third item, that is, which is at the second position in the list, second index position, 23.601 and 2, which is 23.6. Now let us try to move from the last. We're trying to list the second item from the last, -1, -2, which is 11. Let us apply some slicing and dicing to the first list. From the first position, extract three items, 1 to 4, which is again Smith at position 1 to third, 23.6 and none. Okay, 3 items from the first position. Again, a slicing and dicing from the first position till the last position, -1, extract everything. So till 11, it is going to give me everything. Smith, 23.6, none, 11. So continuing with our exercise, let us now declare a dictionary. So here is a dictionary named first dictionary. Remember, a dictionary will always have a key value pair. It is a list with key value pair. John is a key. It has a value john@abc.com. Kelly is a key, and Kelly has the value kelly@xyz.org. So this list basically contains a name as the key and an email ID as a value. So if I say first underscore dict, it gives me the dictionary. So here we will try to list all the keys available in the dictionary named first dictionary. For this, we use a method called keys. So I say first dict.keys, and it gives me all the keys which are there in this first dictionary, which is John, Kelly, and ID. Now in this example, we are trying to list only the values which are there in the dictionary. So for that, we say first dict.values and shift enter. It says John ABC, Kelly xy@xyz.org, and another list. So we now try to extract the value of a key. So Kelly is a key as we declared here, and when we pass a key to the first dictionary, we are going to get a value related to that key. So I say first dict Kelly and it returns me the value associated with it, kelly@xyz.org. So here for the ID in first dictionary, we associated a value as a list itself. So when we pass a key here in this example, first dict ID, it is going to return the list, the embedded list itself. Now here in this example, we are trying to update the value for the key ID. So we use an update method of the dictionary here, wherein we say dictionary name dot update the key for which we want to update and the value which we want to update for that particular key. So when we say this and then we say first dict ID, it has updated the value for the key ID to 32 and 55. And when we say try to list the dictionary itself, it shows that the ID has a value, updated value of 32 and 55, not 23 and 81, which we had earlier while freshly declaring the dictionary. This has been updated now. In order to delete a particular item from the dictionary, we use a del keyword. So the syntax for that is del, the dictionary name, and the key associated with it. So when we say del, first dictionary, and the key, which is ID associated with it, it should have removed this particular key value pair itself from the dictionary. So now let us try to see what is there in the first dict. So if you see, this has been removed. The ID has been removed. Let us look at more examples. We will now dig more into Python. Here in this example, we are using a set method to a list. So when we are using the set method to a list, which has OD, BMW, you see there is a square bracket and we say set, it has been converted into a list with this kind of braces. And when we try to find out what is the type of this variable called auto survey, it returns as a set. Now we declare another variable called auto survey underscore set with this kind of braces with Audi, BMW and these values. Now when we try to execute the same statement again, and here we will say underscore set, we try to find the type of auto survey set. This is also a type of set. Now we have declared two sets, auto survey 1, auto survey 2, with some items. The first set has items Audi, BMW, BM2 BMWs, Ferrari, GM, Mercedes, and the second set we have BMW, Ferrari, GM, Hyundai, Kia, Chevrolet, GM. So if you see, there are duplicates even in the first one and even in the second one. We just try to execute the statement. So having two sets, auto survey 1 and auto survey 2, We use a pipe symbol for the two sets and put the result in another variable called combined survey report. So we use an OR symbol. The pipe symbol is also called an OR symbol. Auto survey 1 or auto survey 2. If you look at the result, which goes into combined survey report, it has eliminated all the duplicates. So BMW exists only once. This Chevrolet and Chevrolet, these are two different things in survey 1 and survey 2. So they are still unique. So they are getting listed. Toyota is listed only once. It has removed duplicates. And for each item, there is only one existence in the combined survey report. So in this next example, we use an AND operator. So we do an AND between the first set auto survey 1 and the second set auto survey 2 and put the result in another variable called common survey report. And when we try to list what is there in common survey report, we see that only the items which are common between the two sets is the result set, which goes into the common survey report. So BMW is there in survey 1 and survey 2. Ferrari is there in survey 1, survey 2. So this is also called an intersection. When we do statistics, we will learn more about intersection. We have declared a list called student list, which contains items Tom, Jack, Nick, Sarah, and Nicole. Now, if we want to find whether Nick exists in the list, we can give a statement like this: Nick in student list, which returns a Boolean value, true or false. So if Nick was not present in the student list, it would have returned the Boolean value as false. So let us check Mark in student list, which is not there in the student list. This returns a false. Now we declare a variable called word with a value encyclopedia. Remember that this is a string of characters. Now if we say T in word, since T is not present in encyclopedia, the letter T, it returns a false. So if I change this to say I, it returns a true because I exists in encyclopedia here. Now I declare two tuples, test score 1 and test score 2, with 3 items in each the tuple. First contains 68, 96, 71. The second contains 92, 87 and 83. Now I declare another variable called test score, wherein I am going to add test score 1 and test score 2 and store the result of this addition in this variable called test score 3. So when I say test score, now if you see, the list has been extended. The test score is extended to 68, 96, 71, which is test score 1, and 92, 87, 83, which gets appended to test score 1, and the result is stored as a single list in test score. Now here I declare two lists which are having strings. One is having 5 items named country list 1, and the other one is having only 3 items in country list 2. Then I declare another variable called country list final, and I try to add the list 1 country list 1 and the list 2 country list 2. Now this add operator is going to concatenate both the lists and put it into a third variable of type list called country list final. So when I try to list country list final, it shows me US, UK, China, Brazil, Mexico, which is list 1, the contents of the list 1, and also the contents of the list 2, which is Australia, Spain, and Italy. The next example, I declare a variable called first name with the value of George, another variable of last name with the value of Washington, and then I declare another variable wherein I'm going to concatenate first name and last name, and between there I'm also going to concatenate a space. So when I execute this and try to see what is there in full name, it is going to show me George Washington, which is a concatenated value between the first and the last name. Let us look at this example wherein I have a tuple with three values 12, 17 and 9, and I multiply it with a scalar value of 3 and store it in a variable called age. Now if we see what is there in the age, it has multiplied this tuple 3 times. Says 12, 70, 79, 12, 79 and 12, 79. The length of the tuple has been increased from 3 to 3 times, which is 9. Now let us try to do the same thing with a list. A similar thing with a list. I declare a list, the name ID, which has values of 101, 23, 77, 45, and I try to multiply that with a scalar value of 2. And when we see what is there in ID, it has again done the same thing, multiplied the length of the list 2 times. So 101, 23, 77, 45 gets repeated 101, 23, 77, 45. In this example, I am declaring a string called friend and multiplying it by 3 and storing the value in a variable called name. Now let us see what happens with this. When we try to print name, friend is repeated 3 times and gets concatenated. So while we try to apply the multiplication operator to a list or a tuple or a string, the length of a tuple, list or a string gets increased by that multiplication factor. Now let us try to get into a bit more advanced topics. Now I declare a function named add two numbers. Remember, a function needs to be declared with a def statement, and it has two parameters, num1 and num2. And what it does is it returns the addition value of num1 and num2. It adds these two numbers and returns the added value. So the next line, I declare a variable number1 is equal to 23, number2 is equal to 47.5, and then I call this function add two numbers with the values number1 and number2. When I pass number1, this is called an argument to a function. So when I pass this argument number1, 23 gets passed here and 47.5 gets passed here, and it goes and calls this particular function which is declared with a def statement, and when it returns the added value, it is going to store it in the variable called result, and then we try to print the result. So this is how we call the function and then assign the value, the returned value, to a particular variable. So let us see what happens here. So it adds 23 and 47.5. The value gets stored in a variable called result, and the result gets printed as 70.5. Here we declare another function called profile. Remember that this indentation is very important because this defines that all these statements are within this function block of profile. So we declare variables which are local to this function, which are available only to the parts of this function. We declare a variable called age with a value of 21, height with a value of 5.5, weight with a value of 130, and we return three values, age, height, and weight, from this function. In traditional languages, normally we can return only one value, but in Python we can return multiple values. So we are returning three values here, age, height, and weight, which are actually local to the function, which are available only to the parts of this particular function block, but we are making it public by returning it. So here is how we need to declare a statement when we return multiple values from a function. So we call the function name on the right side of an equal to, and because it is returning three values, we assign three different variables and call the function with an equal to a function name. So this function, when it gets called, age will get the return value of age, which is 21, height will get 5.5, and weight in this sequence. Let us see what happens when we try to print age, height, and weight. 21, 5.5, and 130. In this example, we declare a list called store list with values McDonald's, Taco Bell, Dunkin', Wendy's, and Chipotle. Now, this enumerate is a specific keyword wherein when we use it with a list, it is going to assign a position to every item internally. So it actually converts the list into an enumerated value, enum, which is normally used in other languages. And then we use a for loop wherein we say position and name in enumerate. So 0 gets assigned to McDonald's, 1 gets assigned to Taco Bell, 2 gets assigned to Dunkin'. And when we say for position and name in enumerate of store list, we are converting this store list into an enum type, print the position and name. So 0 for the first iteration, 0th position, it will print McDonald's. For the first position, it will print Taco Bell, and so on. Just like this. So let us look at another example wherein we convert a store list into an enum and then to a dictionary type and store it in store map, a variable name store map. So for here, what we say is for name position, this is how we need to give a for loop in this case. For name position, name in, we are enumerating the store list, okay, and then we are converting the result into a dictionary. So this is going to define the name as a key and position as a value, and then store it in store map. Let's see what happens in this case. See, it returns a dictionary and it has converted this list into a dictionary with values 0, 1, 2, 3 and keys as McDonald's, Taco Bell. See how we converted a normal list to an enumerate, and from enumerate we converted that to a dictionary type. Here we are going to get a sorted list. So we use the sorted function and we pass a list to it. It is going to sort the list in the ascending order and return the list. Now what happens if we pass a string to the sorted function? The sorted function converts each it actually splits the string into character and then sorts it in the ascending order and then returns it. In this example, we are declaring a range called numList, which will contain the value from 0 to 14. We are using the range function to create a list of range from 0 to 14, and then we are trying to reverse the list and print it. So 0 to 14 in the reversed order, the descending order, it gets printed from 14, 13, 12, 11, 10, 9. Let's look at some if-else statements. We declare a variable called age and assign a value of 21. And then we have an if statement which says if age is less than 18, print minor, else print adult. So in our case, the age is not less than 18. So it is going to print the else statement, is adult. So let us look at another example with if, else if statements, elif statements, sorry. So we here declare a variable marks with a value of 81, and we enter an if elif block wherein we say if marks is greater than 90, print grade A. Elif marks is between 80 and 90, which is marks is greater than or equal to 80 and less than or equal to 90, print grade B. Elif if marks is between 70 and 80, print grade C. And finally we say else if the marks range do not fall in any of these if elif categories, then print grade F. Now the marks is equal to 81, so it prints grade B because 81 lies between 80 and 90. So it is going to execute this particular statement. This is another example wherein we declare a list named stock tickers, which contains a series of strings like AAPL, MSFT, Google, none, Amazon, and then we get into a for loop wherein we iterate this list and then we say if tickers is none. So when we iterate this list one by one, when AAPL, MSFT, when the iteration reaches none, we are going to say continue. So for each other iteration, it is going to print tickers, and if iteration is none, it is actually going to skip the for loop during the iteration. So if you see, it says stock tickers is equal to AAPL, MSFT, Google, none, Amazon. Then for each iteration, it iterates and prints AAPL, MSFT, Google, and when it reaches none, the for loop doesn't get into this particular line of print tickers. It skips this particular line and it again starts from the next item in the list, which is Amazon, and then it prints Amazon, Cisco, and ORCL. So this is a display of the continue statement wherein the continue is used to skip a particular iteration. So let's see this example wherein we use a break statement. A break statement is used to terminate a particular block, a particular iteration. So here for the same stock tickers, what we say is when we reach none, you break from the for loop. Until then, you keep on printing what is there in the for loop for each item. So this is going to print AAPL, MSFT, Google, and the next iteration when it finds none, it is going to break and come out of the for loop. You see it has printed first iteration AAPL, second iteration MSFT, Google, and when it reaches none, it has terminated the for loop and it has come out of the for loop. So this was a display of the break statement. Break skips the iteration, while a break terminates the iteration, while continue skips an iteration. So here is another example wherein we display the usage of a while loop. We declare a variable called temperature with a value of 100, and we declare a while statement saying that until the temperature is greater than 95, while temperature is greater than 95, keep on executing the statements within the while statement. And what we say in the statements is print the temperature, and then we decrement temperature with -1. So initially the temperature is 100. For the first iteration, it is going to display 100. For the second iteration, before the second iteration, the temperature is decreased by 1, which becomes 99. It is then the while statement checks this particular statement whether the temperature is greater than 95. Yes, so it prints 99. Again, it decrements it by 1. 98 is greater than 95. Yes, it prints it. So as soon as it reaches 95, the while loop terminates and it comes out. So it prints 100, 99, 98, 97, and 96. With this, we will come to the end of the exercises for Python. Thank you.